Hello and welcome to Technical with Kranti, and today we are going to see eighth question on recursion. Overall, this is the ninth video on recursion. These are the questions and videos released in recursion, and let's look at the question. So the question is simple to understand, not simple to do probably. You have a Sudoku, which is a 9 cross 9 matrix, and there are some elements filled. So in an unsolved Sudoku, there would be some elements, some cells filled with numbers 1 to 9, and the remainder of it has to be filled by the one who is solving it. So we are given an unsolved Sudoku and we need to give back the solved one. The given Sudoku will have a unique solution in our case. So how are we going to do it? First of all, think about the algorithm. Think about the algorithm only. Coding would come on later. So this is going to be similar. This is going to be similar to the n-queens problem. In n-queens problem, what we were doing, we were checking each cell and seeing whether a queen can come here or not. If it can come, well and good, we'll place it over there. If it cannot come, we'll check the next cell. Here also, what we will do, we'll take a cell and see which number can fit over here. So in a particular cell, in our case in Sudoku, a number will definitely come, but which number will come, which number is valid, that is going to be verified. All right, so let's go ahead and try to solve it. So what we are going to do is we'll first of all run a nested loop. So for I will vary from 0 to 8, and j will also vary from 0 to 8. All right, and we'll see that if board of I j is basically empty. Empty is represented by dot. Okay, so if it is empty, then we will try numbers. So we'll run a for loop for num between 1 to 9. So we'll try 1 to 9 number. All right, so let's suppose I tried number 1 here. Okay, so for this, I need to perform three checks. What are those three checks? First check is whether one is in this particular row. So ELE is in that row. Second check is ELE, ELE means element, is in that column. And third check is ELE is in that box. Now, what is that box? This entire 9 cross 9 matrix could be subdivided into 9 boxes. So, this is one box, this is one box, and this is one box. Similarly, this is one box of 9 elements. This is one box, this is one box, and similarly. So, these are the 9 boxes, and we need to see that one shouldn't be there in that box also. If all these checks are satisfied, then then in whatever elements that are filled, or in whatever cells that are filled, one at this place is fine. All right, so we'll place one here. Now what we'll do, we'll go to the next cell and do the same checks over here and keep on filling the cells. Then later on if we find that we cannot fill any particular number in a cell, then it means that whatever we have filled earlier is wrong, right? So for example, 1 can come here, then 2 can also come here. 3 cannot come. 4, what about 4? 4 can also come here to begin with, right? 5 cannot come, 6 cannot come, 7 cannot come, 8 cannot come. So basically at first position there are three choices available, but we went ahead with just filling one over here. So later on it could be possible that one was a wrong choice. And in that case, we backtrack and try with another possibility, which is 2. So this is done for all the cells. This is done for all the cells. So this this way of trying, this way of trying all the elements in all the cells is called recursion and backtracking. Recursion and backtracking. All right. So let's have a look at the code for better understanding of how this is implemented. All right. Let's have a look at the code. So this is the validity check. For any particular cell, there will be some row value and a column value. And we need to check whether this particular element is not invalid as of now. So what we'll do, we will see. So keeping the row fixed, we'll vary all the 8 values or all the 9 values of the column and see that if that particular element is not there in that particular row. If it is there, return false. Similarly, we'll keep the column constant, vary the row value, all the 9 values. If element is there in that particular column, return false. And this is the check for the complete box. Okay, so this particular thing will ensure that for any particular value of row and column, we get all the indices of that particular box. And if the element exists in that particular box, then return false. So I would say that you take any value of row comma column, for example, 0 comma 0, and for I ranging from 0 to 9, just verify that it gives all the indices of the first particular box. Okay. And if the element does not exist in all these three places, then return true, which means that you can place the element over there. All right. Now let's have a look at the recursion. So this is for row, this is for column, and we'll just see that if that particular cell in the board is still not occupied, then what we'll do? We'll try all the 10 elements and see if I can place that element on that particular cell of the board. If we can place, we'll place it. And after placing, we'll we'll do the recursion and try for subsequent cells. All right. Now, in what condition we'll return true? We'll return true only when all the rows and all the columns are filled. If they are all filled, then we'll return true, which means that whatever element that I filled over here, okay, if that resulted in a solution ultimately, then we'll return true, and then the algorithm will go on towards closure. Otherwise, if this choice was not correct one, then we'll return false at some point. And when we return false, then I'll reset that particular choice which I had set over here, and I'll try another element. I'll try another element over here. All right. I hope it makes clarity and sense to you. Now let's submit it and see if we can. Uh, yes, we have submitted and it is accepted. So I hope you understood the problem and you understood our approach and the code. If you did, please give it a thumbs up and subscribe to my channel. Thank you. Bye bye.